Then welcome, Patrick. I hope you can hear us and see us. Okay, very good. It's kind of difficult for me as the moderator because I cannot, hold up my little iPad with the timing, but I'm sure that won't be a problem. So Patrick is the software development lead for a government organization in Australia. I was not able to find out which one. I'm not quite sure what that gives, but anyway, he's also with OWASP, and he's worked on the OWASP dependency check tool, and that is something that he built on to develop a standard for a software bill of materials that has become an OWASP flagship project. Sorry. So his talk is about creating a software bill of material as a key factor in securing the supply chain, and I'll simply hand it over to Patrick.
Yeah, thanks.
Thanks.
Yeah, I have to admit I'm pretty disappointed that I couldn't make it there in person. I've been seeing people posting pictures online of the beautiful city burn and also seeing people face to face. But thanks for having me all the same. So yeah, I'm co-lead of the OS Cyclone DX SBOM standard project, also an open source software maintainer. I participate in multiple SBOM related initiatives, international initiatives and things like that. And yeah, for my day job, I'm the software development lead for a government organisation down here in Aussie. On the vein of missing out on the in-person experience, feel free to, if you do want to ask me anything or chat to me about this, definitely reach out to me on Twitter or send me an email. Modern software and embedded devices, we don't build them from scratch. We assemble them from a whole bunch of third-party components. And there's some obvious benefits to that. If you're building less, you can deliver quicker. It's much more cost-effective, especially with open source software components. You're typically not paying any sort of license or support fees, but even with commercial off-the-shelf components, they can end up being much more cost-effective than building them yourself. And from my perspective, one of the big benefits is quality. You don't want your average software developer rolling their own cryptography, for example. And in software development, there's a lot of cross-cutting concerns. Application logging, input sanitization, data serialization. There's a lot of functionality that is common across different software systems and also devices. So you want to be reusing well-made, well-tested quality components. But of course, including third-party components brings in different sort of risks. And an example from Australia was the copy-paste advisory. This was put out by the Australian Cybersecurity Centre last year. Led the Prime Minister of Australia to have a press conference on a Friday of all days to announce that Australia was under a cyber attack because there'd been some persistent attacks on Australian organisations from a foreign state-backed actor. The reason it was called copy-paste advisory, because they were basically copy-pasting exploit code off the internet. And there was a whole bunch of CVEs involved. There was one that stood out to me. It was a critical remote code execution vulnerability, and the component it was in was a bunch of user interface controls for web applications. Now, obviously, the nature of the component typically used in internet-facing systems. What also stood out to me was that the CVE and public exploit code had been available for 6 months prior to the copy-paste advisory, which sort of leads you to believe, ask the question, why was this being issued in a federal government advisory? And the simple fact of it was, the people with this component on their network had no idea they were even using it. This was not an open source software component. This was actually a commercial off-the-shelf component. So the people who had it were getting it off commercial vendors because the commercial vendor was paying a license fee for it and bundling it in their software. Now, the impact from that differs of that type of thing differs quite a bit, the type of organisation you are, the sort of industry you're in. But there was a recent report released last month. It was a Ponemon Institute research report sponsored by Sensornet. And it was all about the impact of ransomware on healthcare during COVID-19 and beyond. Just quite a couple of things out of it. The purpose of this research is to understand how COVID-19 has impacted how healthcare delivery organisations protect patient care and patient information from increasing virulent cyber attacks, especially ransomware. The possible adverse impact on patient care due to third-party risks is the biggest pain point in organisations. There's a bunch of information in it, a bunch of different figures, but this one stood out to me a bit. It's the consequences of cyber attacks on patient care. In particular, this part, 23% of the respondents indicated that there was an increase in mortality rate as a result of a cyber attack. Now, I love this sentence out of a recent US President executive order on improving the nation's cybersecurity. In the end, the trust we place in our digital infrastructure should be proportional to how trustworthy and transparent that infrastructure is and to the consequences we will incur if that trust is misplaced. And when there are incidents, whether it's a known vulnerability or an incident somewhere in a supply chain, two questions you want to be able to answer. Are we affected and where are we affected? And we can't currently answer that. The funny thing is, we've got more transparency in other industries than we do in our critical infrastructure. You know, we probably, most of us know someone who's got a food allergy or food intolerance, and they're making risk-based decisions every time they purchase a product from the shop and consume it. And it's really easy for them because we've got food labelling standards. Now, this is a food label from a famous Australian household brand name, Vegemite. Pretty simple, but there's some interesting information on it. Made in Australia from at least 95% Australian ingredients. You know, in this context, it's just about supporting the local economy and businesses. But if you look at it through a security lens, what we're really talking about here is product provenance and pedigree. We've got malt extract from barley. Now, it's quite common in software development to include a dependency, but that dependency's got other dependencies that we call transitive dependencies. Got an allergen statement, just about highlighting high-risk ingredients to make it easy for the consumer. You know, some people are looking for may contain traces of nuts. Security people are looking for may contain traces of struts. But essentially all this does is enables a risk-based approach. And it's not unique to Australia. This is all over the world. You know, got Le Parfait, product over in Switzerland, same thing. You got a food label on it. But there's some interesting stuff about Le Parfait. You know, in 1971, it was acquired by Nestle. So the parties involved in that supply chain changed. The product itself also changed. Up until the 1990s, truffles were one of the ingredients, but it was replaced by black trumpet mushrooms. Now, in the context of food, that's probably not a big deal, except that the product that you remember having as a child is not the same product that you can buy today. But from a security context, that is important information. And of course, figuring out this is the big analogy for what we have in the software world, which is software bill of materials. It's a reasonable analogy. It's handy because it's very easy for people to understand. But we don't really build software the same way you make food. Yeah, it's more like a car. You know, if you think about the dash of a car, within that component, there's other components, like an instrument cluster. And within that instrument cluster, there's other components, like a speedometer. And then within that speedometer, there's things like resistors, perhaps LEDs. And all these components in this nested assembly have different supply chains, different suppliers. A very nice, simple graphic for what an SBOM is from some of the work that came out of the US NTIA work. You know, hypothetically, I'm on the Acme application team. I know all our dependencies. We've got Bingo Buffer and Bob's Browser. Bingo Buffer, we don't know what's in that. In Bob's Browser, we know there's Carol's compression engine. And We don't know everything that's in Bob's browser, but we know that there's no other things included in Carol's compression engine. Now, some of the information in a SBOM, typically, not surprisingly, component name and version, the author and the supplier, because they're often different things. Stuff gets repackaged and redistributed by someone else. A unique identifier. Now, it's going to be different depending on the type of thing that you're describing. I might be talking about a CPE, or if it's an open source software package, much more likely to be a package URL. And license information, perhaps not what you think about when we talk about securing the supply chain, but that can have risks as well. And a good intrinsic identifier. So if you've got something, you can verify that it's the same thing. Now, there are multiple SBOM formats. SPDX, it's out of the Linux Foundation. Started off, it was all about open source software compliance. Think source code audits and identifying all the licenses and copyrights that applied to software. It's also an ISO standard. You've got SWID tags, that's another ISO standard, but once again, coming from a sort of, a different use case, much more traditional software inventory and asset management, license entitlement, that sort of thing. And of course, Cyclone DX, and not surprising, coming to the iOS community, heavy focus on software security use cases and supply chain analysis. And what are some of the use cases for SBOMs? Well, one of them is procurement. Just asking for this information. Does your vendor even know what components that they're shipping? Can you evaluate the quality of the components that they're shipping? Are they outdated? Do they have known vulnerabilities? Product lifecycle management. Particularly there's some industries where devices are in service for a very long time, whether it's a medical device or perhaps it's smart infrastructure and you've got something that's physically installed in the ground or infrastructure somewhere that's going to be in service for a long time, may or may not be getting patched. The company may not even exist anymore. And being able to identify when that device represents an unacceptable level of risk for your organization is pretty important. Software portfolios. This is a very good use case for SBOMs, from the builder side. So if you've got one product that you're developing in one tech stack, it's pretty easy to manage your dependencies. It's pretty easy to keep them updated, pretty easy to identify vulnerabilities. If you've got multiple projects, different tech stacks, different disparate teams, and SBOM provides a single machine-readable format that you can then consume to get a good picture across your entire software portfolio, which is actually how I started getting into this space, because I needed to get an idea of, across hundreds of projects, what sort of state was our software in? Were things being updated? And then if they weren't, why not? Impact analysis. And this isn't just about vulnerabilities in a third-party component. I mean, certainly that is one of those use cases where you can sort of jump on it. But also, when there's an incident in your supply chain, being able to identify, perhaps you've been affected by something, you use something that has been affected by the code coverage issue, where a release was compromised and that was used by one of your suppliers who was building software. Pedigree and provenance. Pedigree, I think, is a big one, especially for commercial software. It's not uncommon for a vendor to take a fork of an open source software project and maintain it internally. There's the leading identity management provider. Last time I checked, they were shipping a known, vulnerable, outdated, unsupported version of a component, but they had taken a risk-based approach to that decision. They had taken a fork of it. They started maintaining it internally. They were backporting all the security fixes. So rather than rushing to an upgrade to the next major version and potentially breaking single sign-on for all of their customers, they were just resolving the vulnerabilities. And provenance, well, depending on the country you're in or the industry you're in, provenance is really important. There might be sanctioned countries involved, or perhaps it's just a company that's got a tight relationship with a foreign government that's problematic. License compliance, once again, perhaps not something that springs to mind when securing the supply chain, but this pops up from time to time. Look at the left pad incident, technically not a license issue, but a trademark issue, or the Ruby off the rails incident recently where they included some GPL code and were redistributing it under a non-GPL compliant license. Integrity, obviously, does the software we got off our supplier match what they said they gave us? Is what we're running in production the same as what our supplier said they gave us? Or is what we're running in production the same as what left our build system? And services and endpoints. Once again, perhaps not necessarily what you think of with a bill of materials, but external services are part of your supply chain as well. There's a lot of similarities between calling code in a DLL that's on disk and calling code that's hosted somewhere in the cloud. It's part of your supply chain. What's the information classification for that, for the communication that's going on? It's the cross trust boundaries. And what are the endpoints involved? How are our devices or systems, are they talking to the things that they're supposed to be talking to? Or perhaps they've started talking to something new. And component risk. And this is where you start getting proactive about things, actually looking at the components either that you're using or that your vendors are supplying to you. I quite like, there's a company called Gitpod, and they went over their full bill of materials. And they went through all the components that they're using. They identified the ones that had really strategic value for them, the ones that were really important for the success of their product. And they reached out to the open source software maintainers, and in some cases they started sponsoring them on GitHub, for example, or maybe they just started contributing back to those projects, increasing the maintainability of their supply chain. How you get started with SBOMs for consumers, I think it's pretty light touch. For procurement, you start asking for this information. Vendors either can provide it or unwilling to, or they're unable to. It's a good indicator of maturity if they can, or if they are even willing to participate in that. I think it's pretty reasonable. If you're, say you procuring a new VPN solution, it's on your network perimeter, provides access to your entire network. I think it's fairly reasonable to ask them, what third-party components are you shipping? What's their versions? And what's the licenses that apply to them? Whether or not they can provide it in machine-readable format's another question, but even just being able to produce it at all is a good indicator. And being able to look at those components, do some basic analysis. Are they 3 major versions behind? Are they not updating their dependencies? Take a realistic approach to this. There's probably going to be known vulnerabilities. They're not all going to be exploitable though. And taken to the next step, I think a very reasonable, low effort way for consumers is vulnerability advisories. Being able to hold your vendors to account. Being able to say, if there is a critical vulnerability in one of the components that you're shipping us, we expect some sort of advisory from you within X number of days. Now, going back to the copy-paste advisory, there are a bunch of people that had no idea they had that component, and the vendor hadn't told them either. 6 months after it, public exploit code was available. Yeah. And SBOM gives you that information where you can actually challenge them on this and follow them up on it. And it's pretty easy to automatically analyze an SBOM to identify those publicly disclosed vulnerabilities. How do you get started as a producer of software or devices? I think this is the big return on investment in terms of SBOMs, because people are producing this stuff, are actually in a place to really make change. But you're not going to start sharing this information with your customers overnight. Yeah, start by being open and transparent with yourself. Look at the quality of the components that you're shipping and the state that they're in. You know, perhaps you've got some issues in terms of where your focus is. You know, a focus on new features all the time is not always good. Yeah, sometimes you've got to take a step back and go, oh, we need to spend some time on quality. Or perhaps you don't have the guardrails in place that your developers can actually upgrade components because they're too scared of breaking stuff because you don't have appropriate testing in place or mitigations like canary deployments, for example. And focus on your high value, high risk products first. You know, probably a bit of a no-brainer, really. Vulnerable dependencies, obviously. You know, and a lot of times you'll find that just upgrading the patch version of a dependency won't break anything and will resolve a lot of vulnerability woes. You don't even need to try and figure out whether it's exploitable in that case. It's easier to just upgrade the patch version. Outdated components, once again, actually monitoring for stuff. You know, some components don't get updated. You know, they'll be put up there by an open source software maintainer, and then they won't touch it for 6 months, 12 months, ever again. And of course, open source software license compliance. Now, if you're shipping a product, open source software licenses are important to look at. And an SBOM gives you that machine readable format to make it very easy to automatically apply policies to make sure that you're compliant with open source software licenses that are compatible with how you distribute your software. And going back to a quote from someone else again, it's much better at words than me. You can't defend what you don't know about. Quite simply, we can't secure a supply chain if we don't even know all the parts of it, all the parties involved, and where things came from, and what was involved in building the software. So I've actually run a little bit early. If you want a bit more information on this stuff, there's some great work that's been done by the US National Telecommunications and Information Administration. Obviously, Cyclone DX website, SPDX website, and the SWID page on the NIST website. And thank you very much for coming along.
Thank you very much, Patrick. Get out of the way. Do we have any questions on the software security? What do you think are the commercial pressures? I mean, it's nice to remind our vendors that, you know, they should do all the good things that you showed, but as a customer, the only leverage I have is with my purchasing dollars, right?
Yeah, absolutely. I think more and more people are going to start asking for this. And so suppliers will be more and more likely to provide it. But also in the US, the US President executive order that I referenced earlier is going to make it a requirement for vendors who are supplying the federal government.
Okay.
Now, there's a whole bunch of people who might be thinking, oh, well, I don't supply the federal government, so it's not going to apply to me. But I think you're probably going to see this ripple down effect where they're supplying someone who supplies a federal government agency. And so now they're being asked for that information by their customers. And I'm starting to see a little bit of movement in terms of vendors trying to differentiate themselves, particularly in light of the executive order, saying, oh, look, we've got an SBOM. And so I think it's sort of reached that tipping point where it's going to, you know, the combination of that executive order and general market pressure. You know, we don't have an executive order in Australia for this, for example, but I think we're going to start seeing it more and more.
Okay, thank you. Are there more questions? Right, 1, 2. Can we trust the government, or should there be a civil society effort behind this? Because, I mean, the government, as we saw in one of our earlier talks today, they are of two minds. On the one hand, they have a defensive mindset, which is good. They want to mandate security. On the other hand, another branch of government has an offensive mindset.
Yeah. So the funny thing is, this all started before the NTIA started this effort. And the NTIA approach has been more about getting a whole bunch of people together to say, hey, we've got this problem across multiple industries, because they're part of the Department of Commerce. They've got no power to, you know, hit people with a stick until they do it, or even offer financial incentives. It's just been about getting people out in the community together to collaborate on this across industries. So although the US government's involved and now you've got the executive order sort of mandating it, it was already happening in the community anyway. Right.
Okay, great. If there are no more questions, then we finish right on time. I'd like to ask for another hand. And Patrick, I mean, I'm sorry that you're not here, because usually you would be getting this. We'll be leaving some chocolate for you in Switzerland somewhere. So when you come over, please drop in and we'll give that to you. Great. Thank you.